When you hear speculative decoding, you probably think it's always faster. The model predicts multiple tokens at once. You keep the good guesses, and everything speeds up. But our benchmarks tell a more complicated story. On consumer hardware, the MTP version of Qwen 3.6 was actually slower than the standard model on short prompts. Let me show you what we found. We tested two variants of Qwen 3.6 35 billion A3B, Alibaba's mixture of experts model, both quantized to UDIQ4_NL by Unsloth. The only difference, one has multi-token prediction speculative decoding with an extra draft layer, and the other doesn't. Same base model, same quantization, same intelligence scores. This is purely about performance. The test bench is a Ryzen 7 with a GeForce RTX 4070 Ti Super. Context window set to 98,000 tokens. Flash attention on KV cache at 8-bit quantization. 11 identical prompts from 30 tokens to 77,000, each generating 256 completion tokens. The MTP variant runs with draft Nmax of 2, the conservative setting recommended for consumer cards. On intelligence, there's nothing to debate. Both variants share identical scores. SWE bench verified at 73.4, Claw Eval at 68.7, Terminal Bench 2.0 at 51.5, TAU3 bench at 67.2. These are strong coding agent numbers, competitive with much larger models, thanks to the MOE design, activating only about 3 billion parameters at a time. Choosing MTP or non-MTP is a performance decision, not a quality one. Now let's talk speed. The headline, MTP averages 66.1 tokens per second versus 64.7 for a non-MTP, a 2.1% lead. Real, but modest. Break it down by prompt length and the story flips. On short prompts under 100 tokens, non-MTP actually wins. 67.5 tokens per second against MTP's 66.5. MTP lost on 3 of 6 short prompts. On 1, it was 10% slower. The draft model simply doesn't have enough context at those lengths to make useful predictions. The speculative overhead costs more than the accepted drafts save. That changes once context grows beyond about 1,500 tokens. On medium prompts, 1,600 to 25,000 tokens, MTP pulls ahead by 7%. 68.4 versus 63.8 tokens per second. At the extreme end, 77,000 tokens, both slow down, but MTP holds a 5.4% lead. More context means better draft predictions, and that's where MTP earns its keep. Now for the hidden cost that doesn't show up in generation numbers. Prompt processing. Before the model generates a single token, it processes your entire input, and MTP imposes a consistent 25% penalty on that phase. Non-MTP processes at 224 tokens per second on short prompts and nearly 1,300 on long ones. MTP drops to 179 and about 1050 respectively. The penalty holds steady at 23 to 26% across every prompt length. The llama.cpp developers have documented this. The draft mechanism requires extra device-to-host embedding transfers during prefill that the standard path simply doesn't need. In real terms, a 2,500 token prompt adds about half a second to your time to first token with MTP. A 25,000 token document, 4 extra seconds of waiting. At 77,000 tokens, 10 extra seconds. Those are seconds staring at a blinking cursor before any text appears. Both variants report all layers as offloaded to GPU. 42 for MTP, 41 for non-MTP. But that doesn't mean every tensor sits in VRAM. With MOE models like this, llama.cpp automatically keeps some expert weight tensors in system RAM when the full model doesn't comfortably fit on the card, even while the layer itself counts as GPU offloaded. That's the real story behind the roughly 500 megabyte gap between MTP's 12,162 megabytes and non-MTP's 12,668 megabytes. It reflects small differences in how that CPU-GPU split gets allocated, not a meaningful advantage of one variant over the other. So which should you use? It depends on your workload. For sustained multi-turn conversations with growing context, MTP wins. You get the 7% generation speedup on medium and long prompts, and the processing penalty is negligible for typical chat links. For single-turn quick questions, non-MTP is better. More consistent on short prompts, no processing penalty, slightly faster answer. For coding, it splits. Inline completions with short context favor non-MTP. Large refactoring tasks with tens of thousands of tokens of context heavily favor MTP. For batch processing, the math depends on your prompt to completion ratio. The processing penalty hits every prompt, but if completions are long, the generation speedup can outweigh it. One final note, the draft and max setting really matters. We tested draft and max of 4 in a prior run, and MTP actually ran slower than no MTP at all, dropping to 58 tokens per second. At 4 drafts, the speculative overhead completely overwhelmed any benefit. And draft N max of 2 is genuinely well tuned for this card. The broader picture, speculative decoding on consumer GPUs is still maturing. A 2.1% gain is real, but nothing like the 2 times speedups reported on data center hardware. If you're running Qwen 3.6 on your own RTX card, try both variants